to sort of dovetail in from our last conversation, Osprey, or rather, when we were talking with Osprey, we did talk about, the catalyst, the idea that a lot of businesses are always trying to do things better, but everyone's obviously focused on their core competency, delivering on the results that they're expected to. So transforming, these programs and implementing new programs isn't always something that sometimes we have bandwidth for. Then there's always the event. There's the catalyst. In this instance, we spoke time, and it was a bit of a build up of ice, and then that sort of was the cascade to the new and improved Cenovus maintenance program. So, Marvin, do you reckon? Could you just tell us a little bit about what it was like in terms of actually finding that hazard, the near miss, and sort of what the early stages were of sort of scratching the head and trying to figure out how it happened and how to avoid it from happening in the future?
Yeah. So what we're talking about is at the refinery during our winter months, we had a PSIF, or a potential series for injury or fatality. And also along with that, we ended up having equipment damage, and the damage to the equipment that happened was the result of a steam leak that was being kind of captured on an existing scaffold that nobody knew about. So we had a scaffold that was built on one of our vessels up quite high, where nobody just did rounds on it. And the steam leak had developed, and it built approximately about a 30-pound ice block, and then it released, and it traveled between 80 to 100 feet. And on its way down, it had clipped 2 cable trays, and it hit a 3/4 inch Schedule 160 nipple, which is attached to one of our ESD valves, which is our emergency shutdown valves. Bent the actual 3/4 inch nipple, which is Schedule 160, so it's quite a thick nipple, 6-inch nipple, and then further continued on going down and hitting a valve and shearing off the valve stem, and then hitting the ground. So during the operations rounds, where it was a potential was through the investigation process, we had discovered that an operator had just recently walked in that area about 30 minutes prior to that ice block falling. So anybody who does a drop prevention calculators, 30 pounds of ice dropping at that distance is basically a fatality. So for us, through the investigations at Cenovus, we take that serious. Like, we want to talk. We don't want to hurt people. We don't want to put people at risk. And this was something that could have easily been mitigated through some type of process. At that time, we just didn't know what it was, because once again, where the ice developed, it was quite high. There was no line of sight from operations or maintenance, just from the location of where it was. There was also a scaffold built that was erected from who knows what could have been a turnaround or an outage, and it was just never captured properly. So from that, where it ends up happening is that we had to develop a need, and then going through as a refinery site that actually is in North America, and we basically have extreme cold changes in weathers. So identifying insulation deficiencies, ice buildup, just those areas of concern that we just didn't know about. And so then I was fortunate enough at that time that we had been doing a couple minor drone surveys. I had Cortland come out and do, we had basically another incident where one of our tanks had froze up from a VRU line, and we sucked the tank in. So we ended up having to send Cortland's drone inside the tank to go and see what the structural integrity of that tank was, to see if we could actually get more information through the investigation. And then from that, Cortland and I talked, and we were like, we got to figure out if, and what I call it is a paper route. And we have a monthly PM strategy now set up to identify those deficiencies and repairs and major buildups of those moments that keep managers and owners awake at night.
I suppose it's what you don't know, and I think I hate to steal it from you because it will be mentioned a couple of times, that I think something we've talked about in the lead up to this is finding it before it finds you. I think that's just like,
yeah,
it's so apt, and it's so sort of universally applicable, I think, across all asset management, not far from just oil and gas, right?
Yeah, well, and that's a part of our whole, like our Cenovus is in most oil and gas industries, and anyone that I work for, we talk about being preventative maintenance. We don't like corrective maintenance. So when we talk about on our site preventative maintenance, we're talking about we find it. So we're finding the deficiencies. That enables us to create notifications in our computerized maintenance management systems. We plan it out. Therefore, it's more cost effective. We schedule it, and then we execute the repairs, as opposed to corrective maintenance where it's finding us. And anything that's corrective is when something finds us, it typically is, it ends up a break-in to schedule. It's typically cost 2.5 to 3 times more than it would have on planned work. We put people more at risk when on unplanned work. That's also a proven statistic. And it basically, yeah, so like that's our philosophy in drone technology. And for us, I know that, I've created those PM strategies within our SAP programs. They pull 6 times out of the year through our winter program. So we basically start in September and we end in April. And it's a monthly drone survey that we do. And it's survey, repair, survey, repair, survey, repair. And then Osprey's team updates and manages the trend spec. And they do that by a tagging program, which was at the very beginning, it was quite convoluted because it was just a lot of data and a lot of pictures. And it was like, there was no organization to it. So I'd actually tasked Cortland and team, I think it was more team than Cortland, about, how can we separate, so that it's very simple for me, so that if anybody ever asks me like how many deficiencies I have, what are severe, what are minor, and basically what is done. And then they just came up with a filing pro system where we divided our business units into areas that are typical to us, and then they just red, green, and yellow tags. And I can go on, I can go on a trend spec at any time, and I can log in and I can go, here's all the ones that I'm still deficient with. Here's all the ones that are completed. And here are the ones that are either minor or have no concern, or there might be work that's happening on another job that I don't have to worry about them quite yet.
And we'll definitely jump into the system component, because I think there's a couple of things that you said there, being able to get those insights straight away. And we'll again talk about actionable insights versus just having some data. But just before we jump off this slide, what do you think made this hazard or this near miss slightly different to the ones that had happened before? What about this was a bit of a catalyst? Was it just how close it was to being, again, on the risk matrix, it ended up being minor, but the potential could have been catastrophic, right? What made this a little bit more unique and a bit more of a catalyst rather than just an event or a near miss?
Well, through the investigation, what it ends up, it risk ranked quite high for us. It ranked as a high in frequency and high in likelihood and severity. So we risk ranked that, and anybody's aware of what a risk matrix is. We risk ranked that as a 5E, they basically high cost potential, fatality, right? Everything that bad could have happened is what happened in this situation. And we were tasked, it initiated the drone program, it initiated our drop objects program. It gave a much more awareness of, we just don't know what's out there. And then we were actually quite surprised through even the first drone survey on just how much insulation and steam leaks we had in our high line. And those are just areas that we just don't see. Operators don't climb up on piping and walk down high lines. And, and although some, people think, oh, it's just out. It's a high line. It's out in the middle of nowhere, right? But now as our industry has increased for process safety risk, and just keeping that product inside the piping, then even that our company has even enabled a freeze protection program, and then we do investigations on freeze piping. So we actually have to. Our asset integrity guys will basically give us the thumbs up or thumbs down on whether or not we can reuse or use a piping circuit that's been frozen. So there's an NDE requirements that come around that as well. So we get to use drone technology, or the drone survey, they actually help us with that as well.
Okay, and I think that's it's. Yeah, I was going to go on. I'd love to go on 10 different rabbit holes, but I'll stick to this particular these talking points. And I suppose to the solution, we'll get a little bit more detail. But it sounds like, and you mentioned it earlier, the solution was, I suppose, the root cause of some of these challenges. Because the challenge, there's the catalyst, there's the event, but the root cause is, well, why did that happen? And it sounds like it was just you didn't know what you didn't know, and then you were surprised. And again, not very unique to Cenovus as an organization by any means. You were surprised to know how little coverage and how surprising some of these findings were. Is that, Cortland, is that sort of consistent with how these programs get stood up from your experience, both with Cenovus and just generally what these catalyst events can be, and looking at programs like this?
Yeah, absolutely. I think there's two things, right? And they're both kind of people starters, right? It's either somebody somewhere thinking it's part of their day-to-day to think about, what could catch us off guard, right? If somebody's got that kind of capacity in their schedule, but more often than not, right? Everybody's got a full plate. Everybody needs 38 and a half hours in a day and, 400 days a year to get the amount of work that's put on their plate. So when we look at the vast majority of cases, everybody's doing what they can with the time and resources that they have. And you're just blind to things, right? So it typically, more often than not, it takes an event to instigate change. And it's typically through exactly this kind of scenario. So in this case, it's ice, right? But it can be flange concerns are another big one that typically lead to the fires and the explosions that we see in the news from time to time, flange management. It can be general, just decay, leaks, structural. It can be a poor scaffold build or something that's kind of a footing has started to let go. It can be ground erosion. Pick your poison, right? There's some trigger that becomes an event and becomes a headache and a real concern for a lot of people. So it's that kind of event that usually triggers these kinds of conversations. What's great now with this, having more of this program kind of carved out and stress tested a little bit at this point, is that we're starting to be able to have a bit of DNA, like this webinar is about, right? We have some building blocks that we're able to talk about and share across different industries, different facilities, and use commonalities to try to be preventive and start the conversation before it's a real problem. So starting to pull it together. Yeah.
No, it's interesting. And I suppose for those that are on the call from oil and gas, you'll be very familiar with it, but across other asset classes, it's an extreme environment. It's a very large geographic spread. And, one asset can go from offshore all the way through to onshore to processing. Again, the asset class, it's not surprising, and obviously I'm not a 20-year expert, but it's not surprising that things can go amiss, right? The scale and size of these assets, again, with everyone else's roles that they have to be undertaking, it seems to be quite common, and hence I suppose why TrendSpec is, and tools like TrendSpec are starting to become the norm slowly but surely. Yeah. So that was the solution, and looking at drones generally as again, finding out knowing what you don't know, rather. And so we spoke about this last time, Cortland, around the 5 steps to actually implementing this. And we spoke a lot about, firstly, the implementation of a program like this is people, process, then technology as the enabler. I think you were alluding to that earlier, Marvin, around getting your paper process right first. And of course, the idea is it's 5 steps and then you're away and it's easy. Marvin, was it as easy? And I'm sure the 5 steps are correct, so certainly not taking anything from Cortland. but more so just the experience of the asset owner. What were some of the challenges as you were sort of starting out? Obviously, there's a technological components that Cortland and Osprey helped with, but what about the internal component of actually, changing some of the culture, maybe ways of thinking, getting everyone to use mobile more? Who knows?
Yeah, because Cortland and I had a pretty good relationship prior to it. We'd already tested drone kind of survey technology for some of our smaller jobs. I thought it to be a rather easy transition to doing it, like setting it up, creating a work scope, like just creating that work scope right off the very bat. What are the needs, right? Like for us, it's like, what are our bad actors? Areas that we can't see, right? Where are operators not going to? Where can we not get that bird's eye view? Like, what's going to catch us? What are known areas where we've had ice fall in the past? Where are some of our insulation deficiencies? We have a tank roof that basically has the whole entire cladding on the roof came off, right? So being able to go and say, at the very beginning, it was just, okay, build routes in these areas and go do the surveys, and let's just see what kind of data that we got. And then from that, we just started fine tuning that information more and more, just so that for myself and a couple of the other planners, when we go into or get these reports or we go into Transpect, we can either look at it from a 3D modeling perspective, or we can just drill down into the folder system that Cortland and group developed for us, right? Like they know our areas. We gave them the correct PIDs and areas that need to be of concern, and they built the routes. Like, there is the human performance issue of it is we introduced a drone onto our site, and one of the things that we had to overcome was Big Brother was watching us, right? Like, oh my God, you guys are.
Is that your own
on what I'm doing?
Big Brother or his bigger brother?
Well, that's just like people see drones, and they're flying around, and then I'm all of a sudden like, and that was on me, right? Because I should have actually sent out a notification site wide saying that, hey, there is a drone on site, and this is the work scope that they're doing, and I kind of own that, and then they're just spying on me, and and my reply to that is,
get back to work.
Yeah, you're not that. You're not that important. It's if I need to spy on you, I'll just come watch you, right? Like, go back. It's okay. And now today it's like, because we do it on a it's like, and now because we've created a PM program and it's on schedule and it's transparent, I don't hear that anymore. It's like, oh, drone's coming. Right. And more so now, the better part of it is that the operations group or permitting issues or issuing authorities, when they know that drones are actually in the area, they already know that we follow their flight plans. They can actually make that communication awareness during the permitting process. Like, hey, there's a drone in that area. Don't worry about it. This is what they're doing. So they get the opportunity to communicate that information to them as well. Yeah, it was pretty easy like that. I didn't find, or like, I know from a company standpoint, this was pretty easy. What we did have as kind of, and I wouldn't even consider it much of a problem, is just that data collection, turning it into a work order notification. That's more basically just the inability for companies to build or work in our SAP model for company reasons. So what ended up happening is that it's Cortland's team gathering that drone inspection survey and then uploading that information into Transpect, putting all their notes in it, which they do an amazing job of, and then getting that information to me in a report in a timely manner. And it's a lot. Like, there's a lot of data that's collected on our site. Well, 2.5 terabytes.
Well,
and the next,
it's good timing, right? Because I think,
and from that, so then we were like,
sorry, Mom, go ahead.
Sorry, go ahead. Oh no, I just saying like, as we progressed, as we keep progressing this, and I'm going, and I'm going, Cortland, I get these reports, and I'm like, oh my God, man, I got this, deficiencies that I should be knowing about, sooner than later. And then what ends up happening is, just having discussions through the team is like, they would basically now to the point is they understand through clear expectations of, if you're seeing a major steam leak, or if you're seeing frost buildup on one of our tank VRUs, or there's cladding that's flapping around in the wind, or something that I have to get to seriously or put hazard mitigation into, we use technology now to on time, right now in the moment, so that I can basically get that information and then communicate that information or those deficiencies off to our operations group, so that when permitting, they understand what hazards exist out in those areas that they don't see. And that's where we're at now. So it works out incredibly well.
Well, and I think this lends itself really well to the idea that we were discussing, Cortland, beforehand. I think you had the analogy of basically someone that takes the image of or does the X-ray isn't necessarily the person that diagnoses the issue. And I think this is really good because, again, the overall theme there is data versus actual insights and actual decision-making intelligence. Because I think, Marvin, to your point, prior to platforms, I want to say only Transpec, but there's others out there. Don't worry about them. There's thousands and thousands of photos, whereas before before something like Transpec, you would have had them in a SharePoint, and you're saying, look, it's in photo 114, photo 203, and it's sort of there to find. So I think the idea of enabling that actual decision from the data, as opposed to just having all this data, I think that's one of the main differences. Is that a sort of fair assumption? And I suppose that's open to Cortland and you, Marvin, as well.
Yeah, I'd say that's fairly accurate, right? We're trying to make the data more accessible in that timely manner that Marvin's alluding to. Continue advancements in that technology, obviously continue to compress that time between collection and delivery, right? Like there's obviously initiatives in ML and AI for kind of a photo or a data triage process. So what Marv was talking about, how it's working right now, isn't necessarily how it might work later this year or early next year, as an example. Right. So yes, we have a process in place right now that for the things that are kind of mission critical or safety critical, there's a communication process that occurs that precedes the formal reporting. But the goal here, and with the continual advancement in the technology and the tools in platforms like Transpec, will allow us to continue to compress that time frame between data collection and data action. So yeah, and you take out all the guesswork of exactly that folder management system. It can be pinged right here with an XYZ location. It can be marked red, as Marvin was talking about, red, yellow, and green. It can be that simple. But with the spatial data, you don't have to read anything to know where it is, right? Think about that from a time response point of view. So that's my stance on that for sure.
Yeah, and I think, Marvin, you mentioned this earlier. It is really that decision time from when you capture it through to actually making a decision on it. It's exactly what Marvin was mentioning yesterday. So all very much consistent themes. And I think, just on the some of the actual outcomes that are on the screen, which is some clear deficiencies, manual and structural integrity, and obviously then there's a lot of data downstream that other parts of the business can use, and dare I mention the corrosion under corrosion under insulation challenge that's sort of ongoing, and I think we'll possibly touch on that in a minute. But I think just giving everyone a little bit more ideas on the actual outcome of some of these programs is again, and you mentioned something earlier, Marvin, 2.5 to 3 times higher costs for reactive or corrective maintenance. Is that, that's often a number that's mentioned by companies like us, by consultants. It's available there, but 20 years of experience on the ground. Is that a real statistic that it does blow out like that if it is a reactive approach as opposed to preventative?
Yeah, it is actually it is a quantitative statistical data that's actually been proven over time.
Mhm.
Other companies, downstream businesses, they study tool time and efficiencies and how to reduce cost. And although it's the costing of the time, it's how many people get hurt
Mhm.
when we're reactive, right?
Mm.
Because people's just natural reaction or commitment to doing the right thing ends up them going and doing the wrong thing because there's just no plan, and not having a good plan is it's bad. It's not cost effective. You end up basically doing things double because you didn't understand the full entire work scope of it, or you may have done something that wasn't necessarily done or didn't need to be done at that time.
Mhm.
Those are some common themes that happen. Inexperience can also be a factor in it. So yeah, that preventative maintenance model, industry standard is that you want your plants to run on a scheduled 80% PM compliance,
Mhm.
right? That's the goal. 20% is basically your kind of minor break-in work or basically fill-in work.
Mm.
That's a strategy. I'm not saying that all companies want to do an 80-20 split. Some like do 90-10, some like do 95-5, right? It depends
Mhm.
on what kind of business unit you run in oil and gas,
Mhm. Mhm.
right?
Well, it's
Um,
no, I was going to say it's good to know that those statistics actually prove out in the real world, in the idea of having preventative maintenance as opposed to again corrective. And I think what we're about to see on the screen here is talking about some of this, some of the data markup. So obviously you're jumping in, you're seeing these insights straight away. Here's the good old fashioned, red, green, yellow, or red, green, amber, depending on where you are in the world. This system is tried and proven, I think, globally. So I think getting that insight straight away, and just on getting that insight, is it other parts of the business that also benefit from this, Marvin, or is it primarily, obviously primarily maintenance, but rather how do other business departments actually benefit from having this data, or from you having accurate data, maybe?
yeah, so we've actually had some of our tech services, our engineering groups have actually reached out to me. For example, we had a spring hanger that was installed during turnaround where the spring hanger gags were actually left in on a 18-inch flare line. So it actually wasn't actually being supported by the spring hanging. It was just actually hanging on the gags itself. So we were able to use Trendspec to actually, I was able to just send the picture into the engineer, and because he needed to develop a work plan scope on how to remove them. So it was nice to have Trendspec and that drone technology during that time. Now, the first attempt with Trendspec, we didn't get the quality that we wanted, but then I just basically had Osprey basically get me a better imagery on the next drone survey in a timely manner. And so that was one example. The other example is that operations, we had a leaky valve on our crude column where one of the nipples was actually threads had actually started leaking. And it was creating both a flammable and a potentially toxic area. So we had the opportunity to use the drone technology as opposed to sending operators on top of a crude column with limited access under an air job, and basically just got pictures, got the drone in there, which is incredibly good. So it helps also, and it was opportunist work. But when we found it, we just then we were able to take those pictures and plan a repair package through the maintenance department with it. So like key, protecting people and equipment, so essential for drone technology and Trendspec.
Couple other things I can add here, Dre, just
Yeah,
that
please.
we haven't necessarily seen in this facility, but seen in other locations, right? Loss of containment does happen occasionally, and sometimes it's slow and gradual. So catching that in remote areas of facilities where people aren't out there all the time, and actually being able to measure out the affected area, like how much loss of containment, that area-based measurement, to be able to flow that right into the cleanup and mitigation, the environmental documentation that needs to happen. That's something that's certainly there. There's also the erosion side of things for things like berms and just slopes, graded road type things. So seeing some applications that aren't necessarily directly with respect to the mechanical side of the facility, but adjacent. And it builds all up the same platform, and the functionalities there in exactly the same manner. Just a little bit more uplift with respect to saying if you wanted to have specific templates and specific data that was associated with that annotation versus here it is, here's the measurement. It can be everything in between, right? So the other thing I'll throw in here is for people that aren't familiar with the system just yet, when we're looking at these photos online or on the screen, everything that is pulled up, you can zoom right in and enjoy the full kind of digital zoom capability associated with these images. So don't think of what you see as all of what you get. In this case, the tools are, again, baked in that we can get a little bit more granular to the point of counting threads if required, right? So you can get really granular.
Yeah, I think that's an important point. Obviously, the model and the quality gets you as far as you need to, but then the tools to be able to actually, as we said before, actually interact, get to a level of 2 mil, 3 mil depth, actually get a good view of exactly what you need, browse the existing photos that were taken to make sure you're cross-referencing all that data. So that's a good point. The ability to interact with it in many different ways is arguably just as important as the quality of the data itself.
And flexibly so, right? So they're not the canned. Yeah, and very flexibly so. So, what we've built for Cenovus, it doesn't exactly match what we've built for another client, doesn't exactly match what we've built for another account, right? You have the flexibility in those tools. And so, world's your oyster kind of thing, right?
Yeah, absolutely. Well, you said it, not me. The world is your oyster with Transspec. Thank you. I'm sorry, Marvin, did I interrupt?
Just to add on to that too, just in terms of picture quality and tagging locations from planning, scheduling, execution, because we actually use rope access teams to do most of our steam and insulation repairs, and these are typically individuals that travel to site. They're not Cenovus employees. Giving them these pictures and these locations, like I'm handing them 40, 50, 60 pictures and going, go do these repairs. And if they've never been on site, when they go do these repairs, they have never been lost. Like there's no downtime, or I don't have to go out and basically pinpoint all these different locations. Like I can give them an overview map, or the operations groups that are basically permitting them and they walk the line, they can actually point these areas and locations out to them quite easily. Where I know that in past employment jobs, it's like you bring new contractors on or new workers and they haven't been to site, and you go through your whole onboarding and then walking the line and explaining work scope to them and going along. So that actually just helps streamline that process with itself, especially when you hand them I'm handing them 40, 50, 60 pictures, right? And going, go work, right?
Yeah.
I need some repairs done. Right.
Same mentality applies to turnaround too. Right. Like, so this is, we're going and making repairs as part of on-stream maintenance, but the same mentality, the same kind of mindset that Marvin just talked about, that early exposure, that situational awareness that can be provided by rich data like this, it can be, I wouldn't say that it's been adopted in full as of today, but it certainly is poised to be an incredible turnaround augmentation tool. So if we can get this into the hands of the contractors coming to site in advance, and you can take off a few hours of everybody getting to know the facility a little bit. I mean, a few hours per person adds up really quickly in a labor budget for a turnaround.
Yeah, I think the turnaround is a really good example, because it's kind of at the extreme end of everything we've been talking about to date, right? It's everything from very much safety, very much operational throughput. How do we maintain? How do we fix all this without compromising on safety and risk? And it's like, well, when we do shut it down, how do we get the most amount of output done within that time, right? So it's about how quickly can I make decisions? Where do I need, I've got the set amount of time, set amount of resources. Where do I deploy those in the next, call it 7 to 10 days, right? So a turnaround is a really good sort of extreme distilled example of needing to make quick decisions, deploy resources quickly, and then get that feedback loop in, and then be able to sort of action some of that insight as well. So really interesting and really on par with, again, the way that the slowly there is but certain adoption. So I think we've got about 5 minutes left, and we'll let anyone that wants to open up for Q&A. We did get a couple sent in, but we'll see if we have time. But Marvin, perhaps your outlook from a Cenovus perspective, and then Courtland maybe afterwards your view more broadly on the industry. What's next for a program like a drone or 3D enabled preventative maintenance program? Is it AI? Is it higher resolution? Is it a different technology of capture entirely? What are your thoughts, Marvin?
I'm still challenging Courtland and Osprey for me. Where I would like to see drone technology going, especially on these high lines and installation areas for us, our steamers, is some type of AI program that is going to tell me whether or not I've got corrosion or insulation issues, or if I've got cold spots on lines, or if I'm losing R value on my insulation. Mm-hmm. And because you get aging plants, and I know in our plant, we're notorious that if we have a line frozen up, and ours is all about heat transfer of our product, we need heat to transfer our product down the pipeline. We need heat on it. So if we we have a tracer that freezes off, or a trap that freezes off, operators are notorious for sticking steam lances down piping and steaming those lines up to warm them up. And then what ends up happening is we've either saturated the insulation inside it, or we've deteriorated it, or we've blown it apart. And we just, with the cladding, we just never know that. The tracing itself, we can, with technology with thermograph, we can identify cold tracers a little bit better. But that AI capability, or being able to program, that's where I'm looking forward to kind of seeing drone technology move forward. Just on those highline piping, those circuits that are problematic, or even more so for us, is those safety critical piping circuits. Ensuring that pipeline doesn't have a plug-in in it, right? Like whatever's going to flare, making sure that has functionality to it, right? There's no plug-in in a vac off gas line, or things that managers go about, right?
Yeah. Well, there's probably a few, and apologies, Courtland, I'll steal your limelight back. There was a quick Q&A that came through the email for Marvin. So how have you found adoption across other teams at Cenovus? I think we touched on this very briefly, but are there multiple teams getting benefit or looking to from now moving forward?
Yeah, absolutely. Because it is particular for just our plant, because this is one of my initiatives, I will promote Osprey drone technology to other downstream businesses, especially. I think that I do believe that our neighboring plant here in Lloyd is going to start taking a little bit more of an eye look on drone technology. Like Courtland could probably answer that better than I am. He's more on that business side. And it's for me that I challenge him. It goes like, it's easy to say no to drone technology and Transbec because you just don't want to know what you need to fix in your plant.
Yeah.
And it's simple. It's a cost, and if you don't know it, you don't have to fix it.
Yeah.
The problem with that is that's not process safety. That's not that we don't. Our business doesn't do that. Like, we do what makes us better. We want continuous improvement programs with Cenovus. We have neighbors that we're responsible for. We're responsible for people. We're responsible for equipment. We're responsible for our reputation, and how they don't do it. There's some fights and some. It's not all. It's money, right? It still comes down to money. Right?
Yeah.
So.
I think it's consistent.
We just see the benefit.
Yeah, I think it's, and to those on the call and to you guys as well, I think we will go maybe just a couple of minutes over if that's okay with everyone. But I think what you're talking about is pretty consistent with any risk-based, not primarily risk-based. Obviously, there's other drivers in oil and gas, but coming from various technology backgrounds in cybersecurity or other elements of risk management, there certainly is if I don't know, there's a plausible deniability sort of element to it, right? Because if you uncover it, then you have to deal with it, which is time, money, throughput, shutdown, whatever the extreme is. But to your point, I think it's cheaper and more effective to just know it up front rather than avoid it entirely, because it'll find you, as you said before, it'll find you
Just
eventually.
take that investment, right? It's just you have to commit to the program and then let the results reveal themselves so that you can actually start to realize the savings over time. You're not going to save on this out of the gate until, to Marvin's point, right, the 2 to 3 times more costly surprise. And
Yep.
it might take one surprise, it might take a handful of surprises, but at the end of the day, they're going to come at some point, right? That's baked into the history that we've got. So stop getting surprised.
Well, with each iteration, you get that feedback.
Do not find a 30-pound iceberg coming down on your plant and shearing off a bunch of equipment on its way down. And I didn't really allude to this, unit. Like, it clipped one of our ESD valves. So had it actually sheared off the airline to that ESD valve, that would have shut our unit down in the dead of winter. Starting a plant up in minus 30 degrees Celsius is not a good day. That is a huge cost. And just the level of frustration of the human performance of that, like sticking guys out on the middle of winter with steam lances trying to heat up lines to get a process unit going for crude, that is not a good day. Oh, and I know that because I've had to do it.
I will take your word for it. But just we've actually got some good questions coming in. So from Ernie, have you done drone work underground, 7,000 feet down, for example?
7,000 is a lot. We haven't been that deep. But when it comes to working underground, it just depends on what your operating temperature is, right? It's just like if we have a hot atmospheric day above ground, there's going to be limits to the technology. Not to say that they can't be mitigated underground with, say, air movement and cooling systems as it gets hotter as you go deeper. But just about all of these systems do have baked in lighting systems and means of navigation without GPS. So in short, yes, possible. Details of what you're looking for and how we go about it requires a little bit more conversation, but possible.
And whatever treasure you're obviously looking for, please share with us. And with the 3 minutes we've got left, another question was, what are the key considerations for organizations looking to adopt this tech from a technical and regulatory perspective? So that's it's probably both of your view of the world, but Marvin, you probably wear the weight of the asset ownership legislation. What's your view on sort of for organizations looking to adopt this tech? Where should they start?
Yep. Call Cortland.
I actually, I just came up from
here's the thing. Like, for me, you either have a want or you have a need. When we had our incident, it became a need very quickly. It wasn't, and then from that, then we just started developing wants. From an asset integrity module, we use drone technology for API tank inspections for non-insulated tanks. That is a huge cost savings, especially on shell and roof. It is one of my initiatives at Cenovus. We use drone technology to pre-plan bad actors for roof repairs, or if we have shell deformations or settlement. Cortland has been on our site a few times helping us out with that. Cortland and I have also discussed on how to basically get UT information through insulation and kind of, and I know he's kind of working on that diligently as well, but he can speak to that more than I can.
So I was actually going to say,
I just love pre-planning.
Yeah, I was going to say, Marvin, we've got now pull steady current that's integrated on the drones for at least general volume thickness testing through installation. There's still the initiative now that people are actually starting to take this technology a little bit more seriously towards making an inspection port that is dockable, if you will, by the drone. So those are still, the PEC is here. It's sitting here in Cochrane. It showed up yesterday. It's the first one in the wild. So that does provide an option within the limitations of pulse steady current. And then there's still the insulation or the inspection port that is certainly still on the table. If I can kind of add a little bit of the technical and regulatory perspective, or the question about adoption, I think it's about doing, there's some homework that happens internally that how much do you want to do as an organization? How much do you want a third party? And find if it's at either end of the spectrum, or if there's a hybrid agreement. And what we're seeing a lot of across industry is that it is highly hybrid or some level thereof, right? Whether it's 90-10 one way or the other, or right down the middle, there are things that are considered low-hanging fruit for asset owners to be able to have a drone and go quickly look at something, versus something that's a more integrated or complex or multifaceted kind of program or niche equipment, right? So it's to have a conversation and kind of plan what the strategy is in the immediate versus what you'd like to see long term. And don't be afraid to engage the service provider. Not all of us are just there to handcuff to services alone. We do work with a good number of our clients to find out what that balance is if they have an internal drone program, and try to share some of that knowledge across. So it's all there. While I've got the mic, I'd certainly be keen to explore the 7,000 foot deep down copper thing as well with Ernie and team there. So that would be interesting for sure.
Well, and
Portland, did you want to touch on like right plans and like land regulations and stuff like that? Like that would be a regulatory thing that you would have to consider.
Yeah, definitely. Right. Like depending on where you are geographically, there are different aviation authorities that will have rules and regulations that stipulate how we have to use these drones. They vary widely depending on where you are in the world. So I guess as a very quick kind of blanket question on that or comment would be to just take that as a bullet point. Go and do your homework, research your regulatory body for aviation, and see what rules are in place for drone technology, and then find yourself an expert to talk about how you navigate that depending on the complexity. Thanks, Marvin.
Awesome. Well, I mean, personally, I think we have enough for another 2, 3, maybe 4 or 5 webinars. I know that you love doing these, Marvin. So perhaps we could do a monthly even. I don't know. Start a podcast. I'm just throwing out ideas. But no, thank you very much. We have gone a little bit over, and personally, I feel because there was some good conversation, some good questions from everyone online that were sent through prior as well. So again, thank you very much, everyone. Thank you, Marvin, very much for your time. And again, Cortland, as usual, thank you very much. We will be in Houston for EDRC come June. So please join us at the stand. Please visit us. Cortland's going to be doing an amazing talk on CUI and sort of some of the advancements and applications of technology there. And of course, we'll be there for the whole time at the stand and in Houston for that week. So please join us at EDRC in June. But otherwise, thank you very much, everyone, for joining, and we'll reconnect soon.
Thanks, everybody. Thanks, Marvin.